Two teams broke the same universe differently. Then 4 million galaxies gave a new answer. Dark energy, it said, is not constant. The gravity matrix. Einstein called one number his greatest blunder. Here at the gravity matrix, we have tracked every DESI release. A century later, that number refuses to stay still. Then DESI pointed at a new kind of evidence. What it found would force Einstein to blink. Tonight, we name the suspect the data found. In Part 1, the Hubble tension marked the crime scene. Two honest numbers, one universe, a real disagreement. Adam Rees and his SH0 team would not stand down. Planck's cold microwave map would not yield either. So the tension stopped feeling like a measurement error. It started feeling like something real in the physics. If the expansion history itself is wrong, one thing must change. Dark energy, the force pushing it apart, must be changing. But nobody had ever measured that change, yet. Then, in 2016, a quiet instrument began taking shape. At Kitt Peak, 5,000 robotic fibers were aligned. Each fiber was a tiny eye hunting one galaxy. Together, the fibers became a forensic instrument. Every baryon acoustic ring, a fresh witness statement. The lead PI, Michael Levi at Berkeley Lab, put it plainly. We built this instrument to answer one clean question. Is W equal to -1 or not? That single parameter decides the fate of everything. Rees's ladder measures distance, DESI measures pressure. Two instruments, asking the same universe different questions. If you like forensic cosmology, subscribe before the reveal. To understand DESI, you must understand sound. Cosmic sound, frozen into the structure of galaxies. For 380 years after the Big Bang, matter and light behaved as one fluid. The early universe rang like a bell for 380 years. When it cooled, those sound waves froze in place. They left rings of galaxies, always the same size. DESI measures those rings across billions of light years. Each ring is a fossil ruler from the Big Bang. And the rulers are not behaving the way they should. Here is the question: if the rulers drift, what is drifting? Dark energy controls the pressure that stretches the rulers. So if the rulers disagree, the pressure itself may vary. Physicists call that variation W of Z, evolving over time. For 20 years, that curve was assumed to be flat. If this investigation is shifting your sky, hit subscribe. Dr. Natalie Palank-Delabruil of CEA-Saclay co-led the spectroscopy. She has spent 15 years building this instrument. When the first-year data came in, the team checked twice. Then 3 times, then once more for instrument systematics. The signal survived every test they could throw at it. Across 3 redshift bins, dark energy was drifting away from -1. The deviation was small, it was also persistent. A single anomaly means little. 3 redshift bins agreeing means much. At 3 sigma, the collaboration had to speak. Zoom out from this single galaxy to the 4 million behind it. Every fiber, every spectrum, every redshift agreeing. Still, the team held the result for 6 quiet months. The error bars were real, too real to ignore. Then, in April 2024, they published the first release. The headlines were careful, the physics community was not. Preprints flooded the archive within days. In April 2025, the collaboration gathered in Berkeley. They had doubled the data. The signal survived. Dark energy is not Einstein's quiet constant. It was stronger in the past, weaker now. That single sentence rewrites the last billion years. The room sat quietly for a full minute. This is the kind of result theorists whisper about for months. The most obvious objection is systematic error. The team spent 2 years proving it was not. Of all the cracks in the standard model, this one keeps us awake. Because it does not fix the Hubble tension, it joins it. The standard model, called lambda CDM, assumed lambda was constant. Constant meaning identical at every moment forever. This evidence tier matters, statistical inference, not a direct image. Yet the inference holds across every cross-check they ran. So either 4 million galaxies are conspiring, or lambda is moving. Physicists call that second option phantom dark energy. Phantom because its equation violates an old, comfortable limit. Read that again. An energy that behaves like anti-gravity on steroids. Now, a single anomalous dataset would not make headlines. DESI did not work alone in the dark. In Chile, DESI had 6 years of weak lensing. In orbit, Euclid scanned a third of the sky. Both instruments saw the same strange drift. 3 telescopes cannot share the same systematic flaw. At this point, it is no longer noise. DES Year 6 analysis reached 4 sigma on its own. Euclid's first data release tightened the constraint further. Fast forward 2 years, those who dismissed DESI now lead theory papers. Dr. Ofer Lahav of University College London put it simply. The cosmological constant was elegant. Elegance was not enough. Still, the error bars allow the standard model to survive. Barely. Responsible science demands we say so, even as the weight accumulates. Now listen, here is what makes this phase so dangerous. Evolving dark energy changes the age of the universe. It also changes the ages of the very first galaxies. Which means the cosmic timeline must be redrawn. And every downstream prediction quietly shifts with it. Structure formation, galaxy counts, void sizes. Even the cosmic microwave background's calibration trembles. For a century, lambda was the simplest elegant answer. A fixed energy woven into empty space itself. Einstein regretted it, then observation resurrected it. Now 4 million galaxies are killing it again. Elegance was never a promise the universe made. The cosmological constant is quietly becoming history. This galaxy cluster's history depends on which theory wins. Fast forward 20 years, and textbooks may no longer read the same. If a reality this deep can break, what else is quietly breaking? Here is what to watch for in the next 18 months. DESI will publish its 5-year dataset. Euclid will complete its second data release. The Vera Rubin Observatory will begin its full 10-year survey. If all 3 confirm, W is not -1, period. If one disagrees, the mystery deepens in a new direction. Either way, this is what science is supposed to do. Not catastrophe, but the quiet sound of a framework updating. Adam Rees and the SH0ES team return to this story. Their Cepheid ladder, once a measurement, now becomes an implication. If dark energy evolved, early expansion ran differently. Which means Hubble's number and DESI's drift are one story. The same crack seen from two angles. And maybe from a third. Because JWST has been watching the first galaxies and finding objects that should not yet exist. Tiny, compact, red populations of them. Little red dots in a universe that had too little time. If dark energy evolves, it buys more time early on. Time enough, maybe, to grow red monsters. Or not, this remains a preprint, not yet peer-reviewed. Treat it as provisional and noteworthy. Because 3 independent cracks are aligning in one direction. If dark energy is drifting, everything downstream shifts. The age of distant galaxies rearranges itself. The fate of all structure quietly changes. The cosmic timeline must be redrawn from scratch. And JWST has been staring at the early universe. What it found was worse than anyone imagined. Part 3 steps into those red dots and the population behind them. We may be the generation watching the pillars of physics crack. That is not a failure. It is the most exciting moment in cosmology. The universe is still writing its own physics in real time. Part 3 arrives next. We will not keep you waiting long. Subscribe now so the red dots find you first.